Hi, I'm Nick Van Pure. This series is a bunch of field lectures from a March 2020 Death Valley field trip for a Cal Poly Pomona Tectonics class. Please excuse the pure quality audio because I came up with the idea to record this at sort of the last minute. Hope you learned something. Okay, so welcome to our tectonics field trip. So we're going to be, the next couple days, we're going to be going up between LA and Las Vegas. We're going to be looking at a bunch of outcrops that a lot of people drive right past without ever thinking about. But these outcrops tell about 1.7 billion years of Earth history, going right up to things that are active at the present day. So yeah, make sure you have your notebooks out. And so this particular stop, so we got off here at Outlet Center Drive, just off of the 15 freeway here, just short of Barstow. And when we get here, there are these sort of strange pink rocks, no outlets to be seen, despite the name Outlet Center Drive. But they're these sort of whitish pink rocks, and these rocks are something known as the Peach Springs Tuff. And so a tuff is a volcanic rock composed of gas that's been erupted, and in this case it's a welded tuff, so you come up and knock on it, you'll see that it's quite hard, so it's they can be welded from a variety of different causes. In this case, probably this is welded because when it fell, it was still hot enough that the rock was nearly molten together, basically. Now, that's all well and good. The sort of interesting thing about the Peach Spring Tuff is this was erupted in Arizona, which is about 200 kilometers away. So this volcanic ash traveled out 200 kilometers without cooling down enough that it was still, near molten and welded together when it landed. Out here near Barstow, it's just a few meters thick. As you can see, it's about as tall as a person. If you look at the bottom of it, it often contains larger pieces of rocks that it picked up, which are, several centimeters in size, which would seem to indicate that it was still moving fairly quickly when it got here. Again, to get from Arizona to here without cooling down much, that's must have been traveling fairly quickly. And so you would not want to have been living in Southern California at that time, or Arizona or Southern Nevada. Basically, you would have been crushed by pyroclastic flows. So, how does this travel? We're not seeing so much an ash fall, a volcanic ash falling sort of gently out of the sky. We're really more talking about having a pyroclastic flow of mixture of ash and gases and dust that's flowing at a fairly high speed, sort of like these big clouds you see coming out of volcanoes. This is not just a sort of regular scale volcanic eruption. This is what we might refer to as a super volcanic eruption. The deposit covers like 100,000 square kilometers, and the total volume of ash erupted is over 1,000 square kilometers. Sorry, 1,000 cubic kilometers. So this is what we'd call an ignimbrite forming eruption, or a caldera forming eruption. In this case, the caldera is in Arizona, and so that caldera would have been this block of land that would have sunk down probably 5-10 kilometers when all that magma was expelled from beneath it. And so this particular tuff, the Peach Springs Tuff, was erupted about 18.8 million years ago. And it turns out this was not the only ignimbrite or big tuff eruption that happened around that time. This was during a period called the ignimbrite flare-up, which we haven't talked about in class yet, but this lasted from about 45 to 15 million years ago. And the reason it's thought to have happened is basically that so there was about 75 million years ago, there was flat slab subduction that was thought to have gone on. So that there's a subducted slab that was parked right underneath western North America. And at some point, that slab, being denser than the underlying mantle, peeled off and sank down into the mantle and was replaced by hot asthenosphere. And when the hot asthenosphere came up and hit the bottom of the crust, it caused massive melting, creating all these basically super volcanoes, these large ignimbrites that covered much of the western United States. If any of you guys ever come on our hypothetical trip to the Queen Canyon Range, there we're right in the heart of a caldera for one of these ignimbrite eruptions. Other interesting things about this rock here, if you come up and take a look at it up close, you'll see it's got some crystals in it, including sort of transparent clear ones, which are sanidine, and there are also some sort of honey-colored ones, which are sphene. Sphene is very rare to find in a tuff, so it's been, if you find a tuff with sphene in it, sphene is a calcium titanium silicate, then you basically know you found the Peach Springs tuff. So people have used that distinctive mineralogy to correlate the outcrops of Peach Springs from all Southern California, Arizona, and Southern Nevada. So yeah, come take a look at it, and you'll see that it's got these sort of rectangular little clear crystals that have cleavage in them. So that's potassium feldspar, or specifically the volcanic variety called sanidine.